Alright, today we're going to shoot a video on the new MacDon series draper header. This one's called the FD75. And to start with, we've grabbed our quick reference card and we're just going to follow the initial settings here. So we've ensured that we parked the combine and header on a level surface, and we made sure that the feeder house is level. We placed the wing lock spring handles in the locked position. We set our guard angle to mid position between B and C on the indicator up on top. We set our reel fore aft to the mid position, and we've got it set at 5 on our reel arm indicator that's located on the right hand side, easily seen from the cab. We lowered the reel completely, and we've made sure that our stabilizer wheels on the slow speed transport are in the field position. We raised the header so the cutter bar is now 6 to 10 inches off the ground. And next we're going to place the header float locks in the unlocked position. In fact, we've already done that. So this will be locked and there's unlocked. So next we're going to set our main header float. So first off, we're going to remove the special torque wrench from the storage position on the right hand side of the combine adapter. That would be right here. We're going to take this wrench out. Okay, so we're going to put the torque wrench in place. And according to our quick card, since we have a 35-foot head, we're looking for 1.5 to 2 on our torque wrench indicator. So we press down on the wrench until it rises and it drops back off. So we want to look at the peak. So we're at about 1.5 to 1 3/4 on our indicator. Now if we needed to make an adjustment at this point, we come into these large springs and we want to make sure that we measure these draw bolts initially. We want to make sure we adjust these springs evenly. So we've preset this head, but we'll go through the steps to adjust the main header float springs next. Okay, so once again, to adjust our header float, we're matching the values in table 1 up here. And if we need to increase our float, which would mean to lighten the header, we're going to tighten these bolts clockwise. Now, I'm assuming we've backed off the jam nuts. We've measured to make sure that we bring these up in equal revolutions. So if I go 2 turns here, I'm going to go 2 turns here. And I'm going to bring that up until my torque wrench begins to read the value in our table. Okay, so now that we've adjusted the right hand side on our main header float, you're going to want to make sure you go to the left side and do the exact same thing. Now that we've followed the parameters and the quick card for adjusting the main header float, we've got it set at 1.5 on this 35-foot head. I want to make sure that I actually get out here on the divider rod, and I'm going to actually lift up on the head and see how it feels and compare this right hand side to the left hand side and see if they feel the same. And both sides are equal. Okay, next we're looking at our quick card, and we finished with main header float. Now we're looking at our wing float, and first of all we're going to want to unlock the wing float, and we're going to remove the cover if you have the new FD75 series draper, the instructions for setting the wing float are on the underside of this cover. So I'm going to put this quick card down, and we're actually going to refer to the instructions on the inside. We've got a nice little decal on the inside of this cover. I like this one because it's color coded. We've got our torque wrench that we're going to install up at the top link, and we have orange down here for a heavy wing. We've got blue for a wing that's too light, and then we have an instruction or a diagram that tells us if we need to go counterclockwise or clockwise with the draw bolt, which will force this knuckle to the left or to the right so that we can achieve a heavier or lighter wing. What we're trying to achieve here is to make sure that the head is balanced, or the wings are balanced rather. What we're looking for is for the wings to be more apt to fall into a frown than a smile. Think about your head in terms of your ground terrain, and if your head is more apt to fall into a smile, then if you crest over a side of a hill and maybe your head needs to hug the ground for a nice clean shave job, it won't be able to do that very easily. So if anything, we want the wings a little bit heavy, more apt to frown, so it'll wrap around a hill as needed, and then when we level out, it'll easily flatten out without problem. So first off, we're going to look for a higher number or more torque required to go into a smile than to go into a frown. So as I press on this wrench to force it into a smile, I'm going to look for a higher number, and then when I pull back to come into a frown, I'm going to look for a lower number or an easier effort on the wrench. So here I'm going to, as we move it, we'll try that one more time. There's about 2.5 to force into a smile. Now to bring it back into a frown, it's hardly any effort at all. There's about 1.5. Let's try this a couple of different times and get an average reading. There's about 1.5 to drop into a frown. So it's going to be more inclined to drop into a frown than a smile. So if we look at our dropping back into a frown, 1.5, smile closer to 2.5, we are within one whole number of our reading between smile and frown. So as long as we're within one whole number, our setting is within the parameters of the operator's manual and the quick card. So that is an acceptable reading.